Hey, Dallas. We're working on, we're just doing some review right now on rectangular prism. So if you need the formula sheet, I'll put it back in the chat for you. We're just working on these two problems.
I'm sorry, I didn't hear what you.
So I was just saying that we're working on these we're working on this one problem. You're finding the surface area and volume of this prism.
Okay, thank you.
No problem. And I'll put the formulas on there as well if you can see them. All right, y'all, we're going to do about another minute and a half, and then we'll go over it. All right, so let's go ahead and go over for the volume. So we know that the length is 20, the height is 24, and the width is 17.5. So to find the volume, we use length times width times height. So you should have done 20 times 24 times 17.5. And so what did y'all get for the volume?
I got 8,400.
8,400 is correct. 8,400.
Feet square.
8,400 feet, right? 8,400
Yeah.
feet. Good. And remember that's cubed. I'm not gonna forget this time.
Cube. Yeah, it's cube.
Right. I don't want to forget this time. And then for surface area, I'll just kind of I'm not gonna write out the entire formula unless you all really, really want me to. But I was just gonna kind of do the breakdown piece. So 2LH. Do y'all want me to go through the whole thing?
Yes, because Margaret's confused.
Please.
Okay, yeah, I don't mind. Okay, so we know it's 2LH plus 2LW plus 2HW. So let's do the 2LH first. I'm going to multiply 2 times the L times the H. So the L is 20 and the H is 24. Plus, then I'm going to do 2LW. So 2 times the length, which is 20, 20 times the width, which is 17.5, plus, and then the last part, which is 2HW. So 2 times the height times the width. So 2 times 24 times 17.5. Okay? So that's the first part. Once you get that part down, it becomes a little bit more easier to solve. But you got to be able to pick out what's the length, what's the width, what's the height. So now when I break it down, I'm going to do each part individually. 2 times 20 times 24, 2 times 20 times 17.5, and 2 times 24 times 17.5. So when I do 2 times 20 times 24, I'm going to get 960. Is that what y'all got?
Mm-hmm. I just said I'm backwards.
960. Then I'm going to do 2 times 20 times 17.5.
620.
And you should get 700, right? Did I get 700 for that? Should get 700. And I have to make sure you double check. And then for the last one, you got 2 times 24 times 17.5. Did you get 700?
Yeah, I got it after. Yeah, I got it.
Okay. And then for the very last one, you should get 840. Okay. Marcus, you good already? You good so far?
Yeah, I got it.
Okay. So now you're left with those two numbers. Those three numbers. So the last thing you got to do is all just add them up. So 960.
2,500.
Yeah, 960 plus 700 plus the 840, 2,500. Yep, 2,500. And it should be 2,500. What were we doing? Feet. 2,500 feet squared. Okay. Any questions, y'all? Any questions between the volume and surface area? All right, so let's keep it going. So like I said, y'all, we're gonna do something a little new tonight, but it's still kind of involving surface area and volume. But it's just like we're just basically talking about another shape. So what I'm going to do is hold on, y'all. Okay. So we're kind of, like I said, we're kind of moving into cylinders at this point. So what I want y'all to do is, well, not y'all do it, but I'm going to show you all something. So let me turn my camera on so I can see. Y'all see me? Y'all can't, my camera isn't on. Y'all can't see me, can you?
No.
Oh, wait, it's coming on now. Okay, there we go. All right. Hey, y'all. All right, so this is a cylinder, right? This is a spray can. But it's a cylinder, right? It's in the shape of a cylinder. So when you're looking at a cylinder, right, what two shapes do you notice? What two shapes make up a cylinder? What two shapes do you all think makes up a cylinder?
A circle, 2 circles.
2 circles for sure, right? A circle on the top, circle on the bottom.
And a cone, a cylinder.
Well, this is a cylinder, but you got the 2 circles, right? You got a circle on the top, circle on the bottom. And what if I were to cut this in half and open it up? What shape would it be then? So if I were to literally split this in half and I wanted to like open it up, what other shape would it be?
A square.
Let me give you close. Very, 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 very close. Well, it could be a square. But okay, let me do it like this. If I got this is a piece of paper, right? Made into a cylinder, right? Made into a cylinder.
Okay.
So you said, like Dallas said, I got a top circle and I got a bottom circle. But if I open this piece of paper up, what shape is it?
Rectangle.
It's a rectangle, right? So you can quickly see that the 2 shapes that make a cylinder are a rectangle, and then also you have a circle on the top and a circle on the bottom. Okay? So when we're talking about what is a cylinder, we're saying that it's a 3D shape, right? We know it's a 3D shape. It's three-dimensional, but it also involves the two circles and a rectangle. So what do we use when we're solving for a cylinder, right? We're talking about the volume or the surface area. The first thing we have to do is identify the parts of a circle, right? So when we look at a circle, I've got these two blue circles here. Few things that we want to make sure that we notice is that one thing, remember, a circle doesn't have any corners, doesn't have any edges, right? It's round, so it's not going to have a corner or an edge. But what it does have is what we call a center. A center is literally exactly what it says. It's just a point that's in the middle of the circle. And mine looks a little bad, but y'all can see it. So you have what you need. And then from the center, when you say a point from the center, oh, let me do that again, y'all. That looks terrible. That looks a little better. So when you have a line that's going from the center to the end of a circle, that is what we call a radius. So I'm actually going to type that in here. That is what you call a radius. So your radius is always from the middle of the circle to the end of the circle. Okay? From any endpoint. I could do it from the center going up, from the center going down, from the center going to the left. That's still always going to be your radius. Now, if I have my center again, let's say I got my center again, but this time I have a line that I'm actually going to draw. Oh, look, I can actually draw a line. But let's say I actually have a line that goes through the center. So from one end to the other end of a circle. In that case, we call this our diameter. Okay, so this is called our diameter. And so your diameter, make that a little smaller. Your diameter is literally going from one end to the other end. So one thing you want to notice is that it takes two radiuses to create one diameter. Okay, so think of that. You have to keep remembering that the number 2. You have to have two radiuses to make your diameter. Or you can say that to find the radius, you have to divide the diameter by 2. And we're going to figure that out in a minute. So when we're building our formula, right, to find the radius, to find the diameter, to find your radius, you have to do the diameter divided by 2. So for right now, I'm going to put D for diameter, divide by 2. So to find your radius, you have to take the diameter and divide by 2. If you're looking for your diameter, this time, let's say you don't know the diameter, but you have the radius. To find your diameter, you have to do the radius times 2. Whatever your radius is, you multiply by 2 to get your diameter. So we're going to do some examples in a minute. But let's say, for example, I have a radius that is, let's say I have a radius that is 15 centimeters. What do you all think the diameter would be? So if 1/2 of your circle is 15, what's the entire length? What's the other side and what's the entire length?
30.
30. Because you're trying to multiply by 2. Remember, you need 2 radiuses to make your diameter. Let's say you have a diameter and your diameter is, what was the number I had in my head? What was the number I had in my head? Let's say your diameter is 44 centimeters. That means from one end to the other end, is 44 centimeters. So what would it be if you're just trying to find the radius? That means you're cutting that in half. So what would your
So
radius be?
22.
22.
22. Your radius is 22 because your radius is half of the diameter. Okay? So your radius is always half the diameter. Your diameter is always double the radius. So you multiply by 2 to get the diameter. You divide by 2 to get your radius. Does that make sense?
Yes.
Okay. All right, so let's go ahead and do some practice. I just want you all to practice that a little bit first before we get into the actual part of volume of a cylinder. So I'm going to give you all about, let's do about 8, probably won't take you that long, maybe like 8 minutes. You're going to find the radius of all of these circles, okay? I've given you the formula for both to find the diameter. You do the radius times 2. To find the radius, you do the diameter divided by 2. Couple of things, when you look at these problems, when you look at these circles, if you see a full line, like a line that goes from one end to the other, that means they have given you the diameter. If they only give you from the center to an end of the circle, that means they're giving you the radius. Okay? So let's do about 8 minutes, and then we'll come back together. We'll come back together to keep going.
It's an old school game, right? DeMar DeRozan, 37 points, 0 of those threes because he didn't shoot any threes. He didn't even try. Beal scored 45 points, 1-0, made threes. But didn't make any. Russell Westbrook had his league-leading 29th triple-double of the season, 22 points, 13 rebounds, 14 assists. And here is Russ talking about, well, Russ.
Me, like I say, every single night and leaving it all on the floor. I honestly believe there's no player like myself. And if people want to take it, pride in
I say that all the time about Russell Westbrook when people say, oh, those triple doubles don't mean anything anymore. They're so easy in today's game. If it were easy, everybody would be doing it. Vince, do you agree with Russ's comments overall?
Yeah, I'm almost talking about saying, yeah, if it were easy, everybody would be doing it. When I look at my stats, I have 5. You understand what I'm saying? He had 5 last week, the last week and a half. You know what I'm saying? So I tell you, I agree with him, man. He a lot of people can get triple doubles, but he's doing it on a consistent basis. Like, he wants to win. He's shown he wants to win. He has the will to win. And it's unfortunate that, yeah, he has not won yet. But you can't question what he brings to the table, what he's trying to accomplish, and his effect on the game. People agree with how he goes about it. But I tell you what, the numbers that he's put, there's not a lot of people.
You trying to tell me?
Every single night. So yeah, I agree with him, man. I mean, you can take it for granted because he does makes it look easy. He makes it look easy. There's a lot of guys who go out there and score. There's a lot of guys who go out there to rebound. But every night, Russell Westbrook.
Here's the thing. When I was with the Oklahoma City Thunder, playing with Kobe, I said that in a playoff game. He blessed them with the Mamba mentality. Kobe Bryant didn't bless a lot of people with the Mamba mentality.
Do your work.
And it's only a few people that I've seen since my playing career and post-playing career that I've witnessed that every possession, every minute, every second, every possession. That's what Russell Westbrook do. We already know this. You know,
Do not copy my house.
that average 20 plus in the league. It was hard to do that. And then you take it to
We do not allow copying. We will not be having that.
Do you understand?
All right, let's do like 3 more minutes and then we'll go over it.
Corey, you don't need no more candy.
The Wizards were struggling. They were alive.
Right, it'll be hype.
People were talking about firing Scott Brooks. People didn't know that Russell Westbrook was still
He
hurt.
gonna be
He never complained
hype.
about it. He said, you know what? Right after the All-Star break, Bradley Beal wasn't there. He took over the team. And they
Do
don't
you
have the
understand it?
best personnel. He took over the squad. And guess what? Now they're in range of the play-in tournament. And guess what? If they get in the play-in tournament, the way that Russell Westbrook and Bradley Beal
Hey, April. Hope you're doing well. April, we're kind of well, we're about to wrap up actually. On talking about not surface area, radius and diameter. Just talking about parts of a circle. So you are free to just kind of continue to listen. I am recording it, so I will definitely send it along with the follow-up email as well, so you can kind of look at what we talked about at the beginning. All right, y'all. So let's go ahead and keep it pushing. We are going to go ahead and go over these problems. Remember, you wanted to find the radius and the diameter of each of these circles. So for the radius for number one, what did y'all get as the radius?
big name
50.
coming straight out of
Radius is 50 because the diameter is 100. Number two, what's the radius and the diameter?
often the truth.
The radius is 10. Diameter is
Damn near from the moon now. I'm pretty sure he was.
And you said the diameter was what now?
20.
Diameter is 20. Let's keep going. And of course, y'all, you know you would add like the feet and the centimeters and parts like that, but I'm just not gonna put that right now. Number 3, what's the radius and diameter?
5.
You said the radius was 5 and the diameter is 10.
Yeah, 10 inches.
Mm-hmm. Let's see, Evelyn. What about number 4?
Okay.
You got the radius and the diameter. Evelyn, what you got?
Radius is 58.
Okay, so
And
now I want you to
diameter is
look at the
29.
circle. Look at the circle. You have that line that's going from one
What
end
is
to another end. So if it's going from one end to the other end, that's actually the diameter. So that
Oh, sorry, my bad. 29.
Mm-hmm. So 58 is the diameter and 29 is the radius. Yep.
Yeah, sorry, my bad.
You're
I had
fine.
it backwards.
No, you're fine. You're fine. Dallas. What you got for number 5?
For the radius, it was 11, and for the diameter, it was 22.
Perfect. And then Jasmine. What about number 6?
The radius is 63. The diameter is 126.
Perfect. Okay, good. So y'all got a good idea of like how to find the radius and the diameter. So I just wanted to kind of go over that just to make sure that y'all understood, because you're going to need to know that once we start getting into volume and surface area of a cylinder. All right, so let's keep it pushing. We're almost done. We're going to wrap up in a minute. So let's jump into the actual idea of what is the volume of a cylinder. Remember, y'all, volume is how much you have on the inside, right? So how much you're filling up something. So filling up a can of soup, filling up like the spray can that I had in my hand, everything that involves the inside of a cylinder, that's the volume. So when we're talking about the volume, we already discussed that whole idea of radius and diameter. And we know that H in this case would mean the height, right? So how tall is your can, or how tall is your cylinder? One thing that we didn't really discuss, but I'm sure you all are probably familiar with it, is this symbol here. This symbol here. This is pi, right? So we use that. Does anybody know what the value of pi is?
No.
So pi, in this case, we're going to keep it like this. It's actually a really long number. But the number that we're going to use for it, the condensed version, is 3.14. 3.14. That is something you are going to want to remember forever and ever and ever and ever and ever. At least try to remember it.
You said it's called pi, P-I-E?
No, like P-I, just P-I.
Oh, okay.
Mm-hmm. Yeah. So actually, it's pi is actually a longer number. It's what you call an irrational number, which means it continues, but it doesn't continue with the same consecutive number. So it's like 3.14159.6 something. It's like a run-on number. But we usually just say it's 3.14. And so we use that pi when we're trying to find the volume of a cylinder. So this is your formula for volume. You use pi, which is 3.14, times your radius, right? We just talked about what radius is, times your radius squared, times your height. Now, if you remember, I think, Marcus, you were the only one that wasn't really with us at the beginning when we first started. But if you all remember, we talked about exponents, right? We talked about what does an exponent look like. This is your exponent. When it says r to the second power, that's an exponent. So you remember, whatever your radius is, you're not multiplying it by 2. You're multiplying it by itself twice. Okay? So I just want to kind of review that with you all so that you don't get that confused. You are not multiplying that squared twice by 2. You're multiplying it by itself. So, and then after that, you multiply it by your height. So we're going to go through 3 problems tonight, just kind of practicing the idea of volume. And then on Thursday, we'll do a little bit more practice on volume, and then we'll try to jump into surface area as well. All right, so let's kind of look at it first. Just kind of watch me how I do it, and then you'll kind of see, hopefully you'll kind of get the idea. All right, so first thing, as always, let's identify what we have on our cylinder. We're given 7 centimeters and we're given 12 centimeters. So we can quickly see that the 12 centimeters is probably talking about our height, right? How tall is this cylinder? The cylinder, is 12 centimeters high. So we already know what the H is. The height is 12 centimeters. Then if I look at the top of my cylinder, is the 7 centimeters the radius or is it the diameter?
Radius.
It's the radius. It's the radius here. So we've already been given our radius. We got our R, we got our H. And we already know that pi is always going to be equal to 3.14. So now we're going to build our problem. So instead of writing pi, I'm going to say 3.14.
I'm not gonna make this house.
And I'm actually going to make this a little bigger, y'all. So there we go. Make it a little even more bigger. There we go. So we got 3.14 times r squared. We know r is 7. So we're going to say 7. Oops, hold on. 7 squared, and then times our height, which is 12. So this is our problem, 3.14 times 7 squared times 12. So what I'm going to do first is I'm going to solve the exponent because that's a problem within a problem. I need to figure out, well, what's 7 squared? So remember, y'all, this is not saying 7 times 2, right? 7 squared is saying 7 times 7. Which equals what, y'all?
49.
49. So now I've got 3.14
Sounds about 49.
times 49 times 12, right? And so now this becomes super easy. Pop it in our calculator. And what did y'all get?
1,846 and 32. 1,846.32 centimeters.
I can't wait right now. Wait, 32. And then we said centimeters. Yep, centimeters. And then remember, y'all, this is centimeters cubed because we're dealing with volume.
Cubed.
And that's your answer. Okay. Any questions? Any questions? Any questions?
No.
Once you all get the formula, it becomes kind of easy once you get the formula because then you just kind of plug it in, plug the numbers in. All right, let's do another one. We're going to do 2 more. Let's do this one. You've got a cylinder that has a height of 18 millimeters. And once again, we're given the radius, which is 10.5. So my radius is 10.5. So let's build the problem. 3.14 times, I love that I have my co-host. I love that I have a co-host right now. Times the radius, which is 10.5. And remember, we want to say 10.5 squared. And then times the height, which is 18. All right, so we're going to solve the 10.5 squared first. Remember, that's 10.5 times 10.5. What y'all get for that?
110.25.
110.25. So Evelyn and Dallas, y'all got that too? 110.25.
Yes.
Yes.
Okay. So now we're going to do 3.14 times 110.25 times 18. It's a big number. What y'all get?
6,231.33 milliliters. I mean millimeters squared.
Mm-hmm. 6,231 millimeters squared.
Millimeters squared.
I'm sorry, not squared, not squared, not squared.
Cube. Sorry.
Cube.
I wrote
That's
cube.
okay. I said the wrong thing too. All right. So let's just do one more, and then we're gonna come to a stop.
I have to go, so I will see you Thursday.
All right, y'all have a good one. All right, so let's do this very last one. We're gonna do, so in this case, y'all, is the diameter or is the radius given? And what, if so, what is the radius?
It's the diameter.
So then the radius would be what here?
6.
Radius is 6. So I'm gonna write that the radius is 6 because it's not actually given to me, and I know that the height is 15. Excuse me, the height is 15. All right, same thing again. We're gonna do 3.14 times the radius, which we just said was 6, and we're gonna say 6 squared. Times 15. All right, so we know the 6 squared. We're gonna solve the 6 squared first. 6 squared is equal to 36 times 15. And then, of course, I'm writing it backwards, but same thing. All right, and so then what did y'all get for, when you multiply that, y'all let me know what you get.
1,695.6.
Yes. Evelyn, is that what you got too?
Feet. Cube. Yes.
Okay, 1,695.6. And what did I say was feet? Feet, yep. All right, so how do y'all feel about this? This is just volume.
Pretty good.
Okay, good.
Cube.
So like I said, on Thursday, we'll do a couple more practice problems with it, but then we're gonna switch over to surface area, okay? And then we'll be almost halfway, sort of kind of done with the geometry piece. It's not that much that you really, really need to know, except for like little pieces like this. So, all right, so I will, let me stop for a minute.